Hey there, and welcome to Nauctis on YouTube. The future of military aviation could involve strapping on a gas turbine jetpack and zooming more than 50 miles per hour toward a target. Gravity Industries, the manufacturer of the jet suit, has demonstrated its high-flying personal jetpack technology during a NATO mountain warfare rescue exercise held in Slovenia in December 2021. The jet suit is powered by 5 gas turbine engines that generate more than 1,000 horsepower and produce 144 kilograms of thrust, allowing for vertical lift of up to 12,000 feet and speeds of over 50 miles per hour. With a typical flight time of up to 4 minutes, it runs on jet fuel, diesel, or kerosene. Founded by Richard Browning in 2016, UK-based Gravity Industries is the only company that exports jetpack suits to militaries around the world. Browning invented the Daedalus flight pack, which enables the wearer to hover and fly. The company, Gravity Industries Flight Club, focuses on building and designing these jet suits. Both the UK's Royal Navy and the US Marine Corps have already adopted jetpack suits for various limited roles. As part of military modernization efforts, Indian armed forces are also expected to use these suits soon. In January, the Ministry of Defense, or MOD, issued a request for proposal for 48 jetpack suits for emergency procurement through a fast-track procedure. These suits might be deployed along the Line of Actual Control, or LAC, with China to bolster the Indian Army's overall surveillance capabilities. Launched in 2017, Gravity Industries believes its technology is ideal for search and rescue as well as medical rescue operations, as demonstrated during the NATO mountain warfare exercise conducted in December 2021. The NATO Mountain Warfare Center hosted a small units leader course in Slovenia from December 6th to 17, 2021, where Gravity Industries participated in an exercise demonstrating its jet suit. Over the past year, the company has showcased the technology's potential military applications. In spring 2021, Gravity demonstrated the jet suit during separate shipboarding exercises with the Royal Marines and the Dutch Maritime Special Operations Force in the Netherlands. In May 2021, Gravity tested the jet suit's capability during the boarding of the HMS Tamar, a Royal Navy offshore patrol ship. The video showed a man wearing the jet suit launching from a patrol boat, flying above the ocean's surface, and landing precisely on the ship's deck. A similar demonstration was conducted in April 2021 alongside Dutch Special Operations Forces, highlighting how the Gravity jet suit can rapidly provide first-foot security, access and boarding ladder installation, target relocation, and self-extraction. Logistics applications are set to be the primary focus of new wearable technology. The Marine Corps is advancing plans to test a wearable robotic exoskeleton called the Guardian XO Alpha. This full-body robotic suit enables one person to perform the work of 4 to 10 people, depending on the task. With the ability to lift and move up to 200 pounds of gear for 8 hours straight, the Guardian XO Alpha allows for a level of physical labor that would be impossible for a single Marine to accomplish alone.
We'll start with this 80-pound Pelican case. How about that? Sounds good to me.
Operating an exoskeleton with 24 motors is no easy feat. Users have access to an operator control panel about the size of an iPhone. The exoskeleton's arms are not strapped, allowing for easy placement in a locked position while the user accesses the control panel. A total of 125 built-in sensors support the Exoskeleton User Environment Link. Recent reductions in sensor technology costs have made this project feasible. Unlike many other exoskeletons, this device aims to provide users with superhuman strength while minimizing the forces exerted on them. The design team prefers not to reduce the forces on the user to zero from a user control standpoint. Controlling the Guardian Exo's arms is highly intuitive. A simple handle at the end of the wearable robot serves as the only connection point with the arm, eliminating the need for straps. Although the handle appears simple to the user, it is sensitive enough to detect and amplify desired motions. In a demo, users were able to effortlessly move a 30-pound weight in front, to the side, or above them within a minute. The software control system multiplies the user's intent without transmitting force in return, and is smart enough to recognize unwanted input, such as hand vibrations or sudden jerks. And the Human Universal Load Carrier, or HULC, is a robotic load carriage exoskeleton developed by Lockheed Martin to assist dismounted soldiers in carrying heavy loads with minimal strain. This hydraulic-powered exoskeleton can support soldiers in carrying loads up to 200 pounds or 91 kilograms on any terrain. The weight is transferred to the ground through the exoskeleton's shoes, preventing the soldier's body from bearing the burden. Originally developed by Berkeley Bionics, now Exo Bionics, in 2008, Lockheed Martin acquired the design license in 2009. The HULC is a third-generation exoskeleton featuring a hydraulic-powered anthropomorphic design and a titanium body. Weighing 53 pounds or 24 kilograms without batteries, it is fully untethered and flexible enough for squatting, crawling, and upper body lifting. The design can be adjusted to accommodate users between 5'4" and 6'2" in height. The HULC is controlled by an onboard microcomputer, eliminating the need for an external control mechanism. This computer enables the system to sense the user's needs and adapt accordingly. The exoskeleton can be removed and packed up in 30 seconds, and its modular components can be swapped for greater mobility when needed. With a range of 20 kilometers when moving on level terrain at 4 kilometers per hour, the HULC supports front and back payloads and allows users to move at a maximum speed of 11 kilometers per hour for long durations and 16 kilometers per hour in short bursts. The system offers various mission-specific attachments and can carry integrated systems like armor, heating or cooling systems, and sensors. The HULC's battery-powered titanium legs transfer the weight of heavy loads to the ground, while the onboard microcomputer ensures exoskeletal motions are tailored to the individual user. Combining Exo-Hiker trademark and Exo-Climber trademark features, the HULC allows users to carry heavy loads during extended missions and rapid ascents of steep slopes or stairs. It enables users to carry up to 200 pounds without restriction, strength augmentation, and reduces the metabolic cost for the wearer, endurance augmentation.